Hi, no introduction, I'm too lazy. Today we're gonna try. I do this so that future me will be embarrassed about. Oh, past me. Okay, no, ignore that. We today, pie day today, pie. So we're gonna try to figure out what exactly pie is. So my first thought is just draw a circle and let's draw a square. Wait a second, let me just draw a square real. Okay, so there's the square. Let's label them real quick. O A B C D. So we know that the S of the square is, so that is this. So let's just call this R, which is equal to 1, easier measure. So the S of the square is just 4, 2 square. The S of the circle is just pi r square or pi. And since this S, the area, the area of the square is bigger than the area of the circle, that shows that pi has 2004, which is good. Pi is 3.14, so that is a good start. Now I'm gonna limit myself here to just this corner here. You will see why soon. Okay, so we have this mini square here because this here has this area of just 1. So we multiply by 4, we get 4. 4, this is the same anyway, so I don't really care that much. So next, I just gonna draw myself. Oh Jesus, how to draw this? Oh wait a second, how? There we go. Nice. This line here, and then we're gonna draw a perpendicular line to that point there. So it should be around that. So read D and go on this E here. We know that this is just a right triangle, right? That's just a right triangle. This here is also has to be a right angle because this is a tangent line. So a little bit quick proof here. If we have an isosceles triangle, which over here will always be an isosceles triangle, right? It will always be an isosceles triangle. This is actually really easy to prove. So this is a square, so the line is 45 degrees, so that is 45 degrees. So this here is this equal to that because this is a right triangle, like right isosceles one, right? And then this equal to that, and so that is 45, so this equal to this. It's just a bunch of mini proving. Need to prove I have limited time. And if you have an isosceles triangle, which I'm just gonna label different one ABC here, and you have the height of that, oh shit, the area of that is always on equal to AH square multiplied by the tangent of this angle here, alpha, right, it's alpha. Why? Because, well, the S of that rectangle is just BC multiplied by AH divided by 2, right? This is the original formula. Since BC is equal to 2 times BH, we have these two as a congruent triangle here, so this side has to equal to the same. That is 2BH multiplied by AH divided by 2, which is 2 cancel. BH multiplied by AH, Jesus. Okay, so BH. Now BH can be written as AH because the tangent of alpha is just BH divided by AH. That means BAH is just the tangent here is it's BH, which means BH is just the tangent of alpha multiplied by AH. So we plug that into there, we get that's just AH square multiplied by the tangent of alpha, and this is span for every isosceles triangle, right? So we have this here, and now we're just gonna use the formula. So we get the pi here has to be less than. Put the 4 because there are 4 here, there are 4. Take the 1 because this is area of 1. Subtract by this area here, which is gonna be the this height here. Now this height is only equal to this, which is gonna this F here. There, that OA subtract by OF. OF. Now OA is just the square root of 2 because Pythagorean, so this has to be square root of 2. So that will be the square root of 2. Square root of 2 there. Subtract it. Okay, don't put it sideways. Easier to see here. Yeah, there we go. Square root of 2 subtract by the radius, which is 1. That's square. Multiply by the tangent of that angle here, there, which is 45 degrees. Okay, so we know the pi is less than this, but can we go further? Well, you can see here they have these little part here. That's so fucking blurry. And so what we can do is continue to dissect this. So let me just quickly dissect that. There we go. So we have this line here. Now we have is that this is obviously gonna be equal because maybe you can prove it yourself. I'm too lazy. I have 9 minutes left before this video collapses. Okay, so we have that, right? And we know that this angle is equal to 2 times this angle. Let me just go to 1, 2, this alpha, right? So we know the alpha is equal to 1 plus 2. Okay, quick highlighting here. And this means, and this angle here is, and since 1 equal 2, let me go 2 times 1, right? Because this here is isosceles triangle. And we need to find this mini angle here. Oh, that angle there, that half of them, right? Divide by 2, we get that alpha over 2, which is beta. We call it beta. I'm not calling it theta because no, 1. So this angle here is equal to this angle here. That is a pretty cool fact, because what it means is we can start generalizing this, and generalizing is good. We need generalizing. We're gonna get pi easily. So first we get pi, and you can now put the equal sign in because this will be an infinite series. We can keep infinitely dividing the circle. So 4 multiplied by 1 subtract by this term here, which I'm gonna call it A0. Now A0 is just a term, the tangent of 45 degrees. Now 45 degrees can be written as 90 degrees, which is this angle here, subtract by 45 divided by 2 to the power of 0. This is clear because 2 to the power of 0 is just 1, and 40 divided by 1 is 45, 90 subtract that is 45, right? So we just need to find this length here. So we need to find DO, OD, oh dear, and OD we can need to find DB because this is always equal to 1 now. DB we can just take AB subtract by, so we're going to assign that, and we know it's going to be equal to A1 square multiplied by the tangent of this angle here, right? Obviously this has to be this. What is it gonna do wrong? Oh, wait. So multiply by this angle there. So considering this plus this are the same. So this, no, wait. Okay, I'm a bit wrong here. So alpha is gonna equal to 180 degrees. Subtract by that 45. We're just gonna call this beta for the time being. And then we divide by 2, so they're going to be 90 degrees. Subtract by 45 divided by 2, and it will keep dividing by that. So just see that yourself, right? I'm too lazy. By 90 degrees, right? 90 degrees, subtract by 45 divided by 2 to the power of 1. And because there are 2 right triangles here, we need to put 2 to the power of 1. You see why I put 1 here? Easier to remember as well. And then we keep dividing. We're gonna keep do that. Wow, beautiful handwriting. Right, and so we're gonna subtract 2 to the power 2 because there are now 4 of that. Right, 2 to the power 2 multiplied by a2 square times the tangent of 90 degrees subtract by 45 by 2 to the power 2. And you can pretty much see where the formula gonna go. That is it, but ignore that. so okay, ignore that Vietnamese speaking. Cough cough. Now we need to find the term here. We know that a0 is square root 2 subtract by 1. a1, what is a1? a1 is equal to this here, right? Which is equal to this subtract by 1. Well, that's all. We're just gonna call that a2 and 1 is equal to OD subtract by 1. Okay, so and OD is just this using Pythagorean. We know that just dB plus 1 square, right? So it's just dB plus 1 square subtract by 1, and dB just AB subtract by AD. So we can derive that as, therefore, 1 subtract by so wait a second. We need to find this length here, which is just a by the cosine. So 1 subtract by square root 2 subtract by 1, which divided by the cosine 90 degrees subtract by 45 divided by 2 to the power 0, because we need to divide this angle here, which is 2 to the power 0. Then, oh my god, my nose. We get dB, we plus 1, right? Obviously, we get that with square, we plus 1, so we get that OD here, put the square root, big square root, subtract by 1, and then we get that is a1. And a2, how to get a2 here? You see, we need to get the variable of dB, and dB is just this term here, right? So what we're gonna get is we need to make a1 to reach this term. So we take a1 plus 1, right, to get rid of that 1, take that square to get rid of the square root, subtract by 1 to get rid of that 1, and then just take the square root again. So we get that is this term here, which is dB. We then gonna subtract it by the square root by a1 itself, right? Because with a1 is here. If you feel like that, yeah, ignore it. I2 divided by the cosine of the angle, cosine of 90 degrees subtract by 45 divided by 2 to the power 1. And this is actually this term here in the square. So we take that square plus 1 square root and just finally subtract it by 1. That is a2. And a3 is just the same thing as a2, but we just replace a1 as a2. So it's just a2 plus 1, take that square, subtract by 1, take the square root, subtract by a1, divided a2 divided by the cosine of 90 degrees subtract by, we need to take the angle from a2, which is just 2 to the power 2, right? We then have to close the bracket, take that square plus 1, and subtract that all the way to 1, and we can repeat, and there we go. That is my way of finding pi formula. Happy Pi Day again, and yeah, I mean, this is stupid. Bye.